Today we will talk about scheduling resources and costs. This chapter discusses the importance of resource scheduling and cost scheduling in creating a master plan for a project. Resource scheduling involves allocating manpower, equipment, and materials throughout the project timeline to optimize their utilization. This schedule serves as a guide for assigning costs to project tasks. Once the resource schedule is established, budgeted values are assigned to tasks based on allocated resources, creating a time-phased budget baseline. This baseline acts as a benchmark for comparing actual costs and schedule progress, enabling project managers to assess performance and make necessary adjustments. Assigning resources to a project network is crucial for transforming it into a schedule. Without resource assignments, the network times alone do not represent a concrete schedule. In most cases, the number of project proposals exceeds the available resources. This scarcity of resources necessitates the prioritization of projects. The project priority team will only approve a new project if the necessary resources are available to accommodate it. Cost estimates for a project do not become a budget until they have been time-phased. Time phasing involves aligning the cost estimates with the project schedule to determine when and how much funds will be required at different stages of the project. Once the resource assignments have been finalized, it becomes possible to develop a baseline budget schedule for the project. This baseline integrates the resource allocations, project schedule, and corresponding cost estimates, providing a comprehensive plan for the project's execution. After assigning staff and resources to the project manager identifies several unanswered questions that need addressing. These questions include concerns about the adequacy and availability of assigned labor and equipment, the potential need for outside contractors, the presence of unforeseen resource dependencies, and a new critical path, the level of flexibility in resource usage, and the realistic nature of the original deadline. To address resource fluctuations, two approaches are to be discussed. If resources are sufficient but demand varies widely throughout the project, resource smoothing can be employed. This involves delaying non-critical activities to lower peak resource demand and increase overall resource utilization. On the other hand, if resources are insufficient to meet peak demands, resource-constrained scheduling is necessary. This involves delaying the start of some activities, which may result in a longer project duration. To address resource fluctuations, two approaches are to be discussed. If resources are sufficient but demand varies widely throughout the project, resource smoothing can be employed. This involves delaying non-critical activities to lower peak resource demand and increase overall resource utilization. On the other hand, if resources are insufficient to meet peak demands, resource-constrained scheduling is necessary. This involves delaying the start of some activities, which may result in a longer project duration. Failing to schedule limited resources properly can have costly consequences and often leads to project delays. Quick corrective action becomes difficult when resource-related issues arise midway through the project. Therefore, procedures such as resource leveling and resource-constrained scheduling are important for project managers to effectively manage resource utilization and availability. The chapter provides an example of planning a wedding reception to illustrate the impact of resource constraints on activity sequencing. It demonstrates that resource constraints take priority over technical dependencies, leading to a different set of network relationships. The resource constraint may require sequential execution of activities instead of concurrent execution, but all activities must be completed before the reception can take place. This explains why resource availability is not factored in during the creation of the original network. Resource availability may not be known until the initial schedule is completed, and assessing the impact of resources requires a resource-neutral schedule. It also examines the interactions between time and resource constraints before the project begins, can uncover unforeseen problems. Project managers must carefully schedule resources to ensure their availability in the right quantities and at the right time. Fortunately, computer software programs are available to identify resource-related issues during the early planning phase, allowing for corrective changes to be considered. These programs rely on activity resource needs and availability information to schedule resources effectively. Technical or logical constraints in project management pertain to the inherent sequence of activities dictated by dependencies among tasks. For instance, foundational work precedes erecting walls in a construction project. In contrast, resource constraints involve availability and interrelationships of resources like personnel and equipment. Resource constraints dictate sequencing due to resource scarcity or unique requirements, such as a specialized piece of equipment needed for a specific task. Resources play a significant role in project management and can greatly influence the way projects are managed. Here are three key types of resources and their impact. 1. People. Human resources are crucial to project success. They bring diverse skills and expertise to the project, such as programming, engineering, welding, marketing, and supervision. Each skill set is typically unique, making resource scheduling complex. While some skills may be interchangeable, productivity may suffer. Managing the availability and allocation of skilled personnel is essential for effective project management. 2. Materials. Project materials encompass a wide range of items, including chemicals, concrete, survey data, and more. Material availability or shortages can cause project delays. When the lack of material availability is anticipated, it should be considered in the project network plan and schedule. For instance, projects with strict time windows, like delivering and placing an oil rig tower in a limited summer month or resurfacing structures on the Golden Gate Bridge, require precise material scheduling. In product development, scheduling materials is also critical to meet time-to-market goals and prevent loss of market share. 3. Equipment. Equipment is typically categorized by type, size, and quantity. While some equipment can be interchangeable to improve schedules, it is not the norm. Equipment constraints are often overlooked, with assumptions made about resource adequacy. However, in multi-project environments, where resources are shared among projects, it is important to maintain a common resource pool. This approach ensures availability checks across all projects and reserves equipment for specific project needs in the future. Recognizing equipment constraints early on can prevent high crashing or delay costs. Understanding and managing resource constraints, whether it's the availability of skilled personnel, materials, or equipment, is vital for effective project planning and execution. By considering resource limitations and incorporating them into project scheduling, potential delays and associated costs can be minimized. Many scheduling methods in use today require project managers to determine whether their project is time-constrained or resource-constrained. To make this determination, project managers can refer to their priority matrix. One straightforward test is to ask whether resources will be added to get back on schedule if the critical path is delayed. If the answer is yes, the project can be assumed to be time constrained. If the answer is no, the project can be assumed to be resource constrained. A time-constrained project is one that must be completed by a specific date. In this case, resources can be added as needed to ensure the project meets the imposed deadline. While time is the critical factor, resource usage should be kept to a necessary and sufficient level. On the other hand, a resource-constrained project assumes that the available resources cannot be exceeded. If the resources are inadequate to meet the project requirements, it may be acceptable to delay the project, but only to the extent necessary. In scheduling terms, time-constrained projects have a fixed project duration and flexible resources, whereas resource-constrained projects have fixed resources and flexible time. The methods for scheduling these types of projects are explained in the subsequent section. In order to focus on the core problem and demonstrate the allocation methods effectively, the chapter makes certain limiting assumptions. These assumptions are essential for the remaining content of the chapter. The two key assumptions are as follows. 1. No splitting of activities. The assumption is made that activities cannot be split, meaning that once an activity is started, it will be worked on continuously until it is completed. Splitting refers to the practice of interrupting work on one task, temporarily assigning resources to another task, and then reassigning them back to the original task. While splitting activities is a common practice in real-world project management, it is excluded in this context to simplify the learning process. 2. Fixed level of resources for activities. The assumption is made that the level of resources assigned to an activity remains constant and cannot be changed. In reality, resource levels may fluctuate based on availability, priorities, or other factors. However, for the purpose of learning and understanding allocation methods, the assumption of fixed resource levels is made. Although these assumptions do not align with real-world project management practices, they serve the purpose of simplifying the learning process for new project managers. By introducing these concepts without the added complexity of splitting activities or changing resource levels, it becomes easier for beginners to grasp the fundamental principles. As project managers gain experience, they will encounter the reality of splitting activities and adjusting resource levels as necessary in their actual projects. Leveling or smoothing techniques involve delaying non-critical activities with positive slack in order to reduce peak resource demand and fill in resource valleys, all without impacting the overall project schedule. The main goals of smoothing resource demand are: 1. Reduce the peak of demand for the resource. By redistributing resource requirements, the highest demand periods are lowered, resulting in a more balanced utilization of resources. 2. Reduce the number of resources over the life of the project. By optimizing resource allocation, it may be possible to decrease the total number of resources needed throughout the project duration, leading to cost savings. 3. Minimize the fluctuation in resource demand. Smoothed resource allocation helps to avoid drastic fluctuations in resource requirements, making resource management more manageable and predictable. However, there are downsides to smoothing resource demand. 1. Loss of flexibility. As slack is reduced by delaying non-critical activities, the project schedule becomes more rigid, limiting the ability to accommodate unexpected changes or disruptions. This reduced flexibility can make it challenging to adapt to unforeseen circumstances. 2. Increase in critical activities. By reducing slack, activities that were previously non-critical or had a comfortable buffer may become critical or near critical. This increases the risk of project delays if any of these activities encounter setbacks or delays. It's important to strike a balance between resource smoothing and maintaining project flexibility to mitigate the downsides while achieving the desired goals of resource optimization. When dealing with time-constrained projects, the focus is on optimizing resource utilization. However, when the demand for a specific type of resource is erratic, managing and achieving good utilization can be challenging. To address this issue, practitioners have employed resource leveling techniques that aim to balance the demand for resources. These techniques involve delaying non-critical activities by using positive slack, thereby reducing peak demand and filling in resource valleys. Let's take the example of the botanical garden project, which uses backhoes as the only resource. All backhoes are interchangeable. The top bar chart displays the project's activities on a time scale, with dependencies indicated by vertical connecting arrows. Horizontal arrows following activities represent activity slack, and the shaded activity duration blocks show the number of backhoes required for each task. Since this project is declared time-constrained, the goal is to reduce the peak resource requirement and increase resource utilization. By examining the early start (ES) resource load chart, it is identified that the fence and walls activity has slack that can be used to smooth the resource needs. Delaying this activity results in a smoothed resource loading chart, where the resource profile is improved and the number of backhoes needed over the project's duration is reduced from 4 to 3, a 25% reduction. The smoothing technique achieves several goals. 1. Reducing the peak demand for the resource. 2. Decreasing the total number of resources required throughout the project. 3. Minimizing fluctuations in resource demand. Smoothing improves resource utilization, particularly when resources like backhoes or people cannot easily be moved between different locations or projects. However, leveling has a downside: the loss of flexibility due to reduced slack. By reducing slack, activities may become more critical, increasing the risk of project delays. Pushing leveling too far to achieve a perfectly level resource profile can be risky, as every activity becomes critical. While the botanical garden example provides insight into the time-constrained problem and the smoothing approach, real-world projects can be much more complex, even for small projects. Manual solutions are impractical, but modern software packages offer effective resource leveling routines. These software tools often prioritize activities with the most slack, assuming they pose the least risk. However, it is important to consider other factors such as flexibility, activity complexity, and overall project risk when choosing the best leveling approach. Experimenting with different alternatives can help find the most suitable solution that minimizes the risk of project delays. The resource-constrained problem arises when there is a shortage of people or equipment to meet the peak demand requirements of a project. In such situations, the project manager must prioritize and allocate resources effectively to minimize project delays without exceeding resource limits or disrupting the project's network relationships. Solving the resource allocation problem mathematically becomes impractical for larger projects due to the massive data requirements. Therefore, heuristics, which are practical decision or priority rules, are commonly employed to tackle complex resource allocation problems. Heuristics may not always yield an optimal schedule, but are effective in generating a good schedule for projects with multiple resource types and complex networks. The efficiency of different heuristics and combinations of rules has been extensively studied. It is advisable to test several sets of heuristics on a project's network to identify the priority allocation rules that minimize project delays. The parallel method is a widely used approach for applying heuristics and has consistently proven effective in minimizing project delays across various projects. It involves an iterative process that starts from the beginning of the project and prioritizes activities based on specific rules when the required resources exceed the available resources. The priority rules applied in the parallel method are as follows. 1. Minimum slack. Activities with the least slack, i.e., the least amount of time available before they become critical, are scheduled first. 2. Smallest duration. If activities have the same slack, the activity with the smallest duration is prioritized. 3. Lowest activity identification number. If activities have the same slack and duration, the activity with the lowest identification number is scheduled first. Activities that cannot be scheduled without delaying others are pushed further in time. It's important not to move activities that have already started. When multiple activities require the same resource in a given period, the priority rules are applied to determine the order of scheduling. The parallel method continues until the resource limit is reached. At that point, the early start of succeeding activities not yet scheduled will be delayed, and their slack will be reduced. This process is repeated in subsequent periods until the entire project is scheduled. Okay, let's take Electronic Medical Records Project EMR as example for the resource shortage. The EMR project involves the development of a handheld electronic medical reference guide for emergency medical technicians and paramedics. However, a resource problem arises due to a shortage of design engineers and their commitments to other projects. As a result, only 8 design engineers can be allocated to the project. The peak demand for design engineers, as determined by the project requirements, is 21. This means that ideally, 21 design engineers would be needed to complete the project efficiently and effectively. However, due to the limitations, only 8 engineers can be assigned to work on the EMR project. This resource problem poses a challenge in terms of meeting the project's demands and timelines. It requires careful resource management and allocation to ensure that the project can progress despite the constraints. The project manager will need to make strategic decisions and potentially adjust the project schedule or seek alternative solutions to address the resource shortage effectively. Okay. The implementation of a limited resource schedule brings about several effects, including a reduction in slack, decreased flexibility, and an increase in critical and near-critical activities. Slack, representing the time an activity can be delayed without impacting the project's duration, diminishes in a limited resource schedule, leaving less room for adjustments. Flexibility to accommodate changes also decreases significantly, making it challenging to handle unforeseen events. Moreover, resource constraints lead to more critical and near-critical activities, increasing scheduling complexity. Activities may have 2 constraints for start times, altering traditional sequential critical paths. Additionally, the criticality of activities may shift based on the interplay between time and resource constraints. Overall, managing a limited resource schedule requires careful consideration to ensure successful project execution within constraints. Now we have splitting tasks. Splitting tasks is a scheduling technique that aims to improve the project schedule or increase resource utilization. It involves dividing the continuous work of an activity by temporarily interrupting it and assigning the resource to another activity for a specific period. Afterward, the resource resumes work on the original activity. This technique can be beneficial when the work involved does not incur significant start-up or shutdown costs, such as moving equipment from one location to another. However, it's crucial to be cautious when applying task splitting, especially when it involves people work with high conceptual start-up and shutdown costs. For instance, if a bridge designer is interrupted to work on the design problem of another project, it can lead to a loss of time and efficiency. Shifting gears between activities may incur hidden costs and impact productivity. The interruption can disrupt the designer's flow and require time to re-engage with each project's unique challenges. This figure illustrates the nature of the splitting problem, where the original activity is divided into three separate activities, A, B, and C. The shutdown and start-up times associated with splitting extend the overall duration of the original activity. Studies have reported that task switching can result in a loss of efficiency ranging from 20% to 40%. Therefore, relying too heavily on task splitting can contribute to projects failing to meet their schedules. It is advisable for planners to minimize the use of task splitting unless the costs associated with splitting are known to be small or when there are no alternative solutions to address the resource problem. While computer software may provide the option to split tasks, it should be used sparingly and with careful consideration of the potential impact on productivity and project outcomes. It is crucial to recognize that when resources are genuinely limited and activity time estimates are accurate, the resource-constrained schedule will reflect the reality of project implementation rather than the time-constrained schedule. Failing to effectively schedule limited resources can lead to significant problems for a project manager. Creating a resource-constrained schedule before the project begins provides the opportunity to consider reasonable alternatives. If the schedule delay is unacceptable or the risk of delay is deemed too high, reassessing the assumption of being resource-constrained becomes necessary. Cost-time trade-offs can be evaluated, and priorities may need to be adjusted to find a feasible solution. Resource schedules offer essential information for preparing time-phased work package budgets with specific dates. Once established, these schedules enable project managers to quickly assess the impact of unforeseen events such as turnover, equipment breakdowns, or the transfer of project personnel. Having resource schedules in place also allows project managers to evaluate the flexibility they have over certain resources. This is particularly useful when they receive requests from other managers to borrow or share resources. By honoring such requests, project managers can build goodwill and establish a mutual understanding that can be reciprocated in the future when they require assistance. Project managers must carefully consider the qualifications, experience, and growth opportunities of team members when assigning tasks within a project. While matching task demands with team members' skills is crucial, overloading the most skilled individuals with difficult tasks should be avoided to prevent resentment. It's essential to provide growth opportunities to less experienced members to foster their development and motivation. When forming teams, factors such as compatibility, complementary strengths and weaknesses, and experience levels should be taken into account. Pairing veterans with newcomers facilitates knowledge sharing and accelerates learning curves. Anticipating future needs and facilitating early collaboration among team members fosters effective working relationships. The former CEO of Google offers valuable insights on team composition, as discussed in Practice 8.4, Managing Geeks. In essence, balancing task complexity with talent development and considering compatibility, experience sharing, and future needs contributes to the success of the project team. Okay. In a multi-project environment, resource allocation poses complex challenges as organizations must balance and reconcile the demands of multiple projects with varying priorities, requirements, and risks. Three common problems encountered in managing multi-project resource schedules include overall schedule slippage, inefficient resource utilization, and resource bottlenecks due to critical resource scarcity. To address these challenges, companies establish project offices or departments responsible for overseeing resource scheduling across multiple projects. Various approaches, such as first-come, first-served rules or centralized scheduling processes, are employed to optimize resource allocation and prioritize projects based on their importance. Modern project management software facilitates prioritizing resource allocation and identifying resource bottlenecks, allowing for timely adjustments to project timelines or resource acquisition. Additionally, outsourcing non-critical projects or specific project segments to contractors or consulting firms is a strategy to overcome resource allocation issues and efficiently manage project workloads.
Thank you for watching. If you liked this video, please like and subscribe to channel.